So today we're going to be factoring trinomials with lead coefficient greater than 1. So what I mean by that is even if we are able to pull out a GCF, the number in front of our first term is not going to become 1. So we're going to have to change our rules up just a little bit. So they remind us here that when we're factoring, we cannot forget our first step. We always have to look for a GCF first. So keeping that in mind, when I look at number 1, I'm looking for a greatest common factor that will go into all three of these terms, and that would be 5. So I'm going to pull out a 5, and I'm going to be left with 3p squared minus 2p minus 5. So, like what we did last time, there is no way to get rid of the 3, and last time we would have had a 1 here. So our rules are going to change just a little bit, because normally I would put x and x, or p and p, in my parentheses, because p times p gives me p squared, or x times x gives me x squared. But I need whatever I have in there to multiply to give me 3p squared. So I'm going to have to use 3p and p. If I multiplied these two terms together, I would get 3p squared, which is what we had here. Alright, now just like when we were factoring last time, I do look at my sum and my product. And these are going to help me determine what numbers I put in my parentheses. But when I'm looking for my sum, I'm not going to be looking at the numbers I put in. I'm going to have to check the inner and outer pieces of my parentheses to look for my sum. So I still look at the product to determine what numbers I want to use. So I'm trying to think of numbers that multiply to give me 5. So I probably would use 1 and 5. So I'm going to plug those in. But now I have to check, like I said, the inner two pieces, and I would multiply them together. 1 times p would give me 1p. And then I check the outer pieces. 3p times 5 would give me 15p. And I need these two, when added together, to give me my sum of negative 2. There is no way for me to add 1 and 15 and get negative 2. So I must need to write this in a different way. So let me try again. We have that GCF of 5 out in front, and then we're going to make our two parentheses. We know we have to have 3p and p in the front. Now, it did not work when I had the 1 here and the 5 here, so we're going to switch their places and then check again. So if I multiply these two terms, I have 5p, and if I multiply the outside terms, I have 3p. There is a way for me to add 5p and 3p and get negative 2p. I would just need the 5 to be negative and the 3 to be positive. Well, the 5p comes from these two pieces, meaning I would need to make the 5 negative. The positive 3p comes from the outside pieces, meaning that I would need to make that 1 positive. So that works. And if I was to multiply this out, 3p times p would give me 3p squared. 3p times 1 would give me that 3p. Negative 5 times p would give me negative 5p, which, if I combine my like terms here, would give me negative 2p. And then if I multiplied negative 5 times positive 1, I would get that negative 5 out there on the end. So these are my factors. I had that GCF of 5. My first parenthesis was 3p minus 5. And my second parenthesis is p plus 1. Alright, let's try another one. On number 2, the first thing I should be doing is looking for a GCF. There is no GCF here, so I'm not going to be able to factor anything out. So I go ahead and make my two parentheses. Whatever I put in the front has to multiply to give me 2n squared. So it must be 2n and n. I'm still going to use this sum and product to determine my terms and their signs. So first I'm looking at 9. What multiplies to give me 9? I probably think of the factors 3 and 3. So I'm going to put those in. But to check their signs, I have to check the inner by multiplying these two terms together, which would give me 3n, and the outer by multiplying these two terms together, which would give me 6n. Now, when I add these two terms together, they have to give me my sum, which is positive 3n. The only way I can get a positive 3n is if I have a positive 6n minus 3n. Now, if I want this to be a negative 3n, I have to put a negative with the 3. And if I want the outside to give me a positive, I'm going to have to put a positive with the second parenthesis 3. So again, if I were to multiply this all back together, 2n times n would give me 2n squared. Negative 3 times n gives me negative 3n. 2n times 3 would give me 6n. And if I combine those like terms, I would get positive 3n. And then negative 3 times positive 3 would give me negative 9 out here on the end. So these must be my factors. 2n minus 3 and n plus 3. Okay, number 3. I am looking for a GCF first. So there's not any numbers I can pull out, but they do all have a variable of x in common. So I'm going to be able to factor out an x. So if I pull out 1x, I'll be left with 3x squared minus 8x plus 4. Alright, so now I'm going to have to make my two sets of parentheses, and whatever I put at the front of my parentheses has to multiply to give me 3x squared. So it must be 3x and x. I'm then looking for numbers that multiply to give me my product. So when I'm thinking of what multiplies to give me 4, the first thing that comes to mind is 2 times 2. Now I have to look at my sum to decide what my signs should be. So I check the inner here. 2 times x is going to give me 2x. And then my outer, 3x times 2 gives me 6x. And I need these two, when added together, to give me negative 8. So if I need them to be negative 8, both of these terms have to be negative. Therefore, I have to put a negative in both parentheses. So my final answer would be x times 3x minus 2 times x minus 2. Okay, let's try another one. Number 4. So there is no GCF for me to factor out, so I go ahead and make my two sets of parentheses. Whatever I put here and here has to multiply to give me 5n squared, so it must be 5n and n. I then look at my product, and it's 12. So I'm thinking, what multiplies to give me 12? Maybe 6 and 2. So I'm going to plug those in here. But to see if I'm correct, and if those are going to give me my sum, I have to check the inner and outer. Well, if I multiply the inside terms, I get 6n. If I multiply the outside terms, I'm going to get 10n. And there is no way for 6 and 10 to give me 19. So this must not work. So I try again. And I'm thinking maybe I just need to switch their places like we did on number 1. So I'll put the 2 here and the 6 here. And I have to check the inside terms, which would give me 2n, and the outside terms, which would give me 30n. Again, there is no way for these two to give me my sum, which was 19. Okay, so 6 and 2 must not be my factors. So now I have to think about what else would multiply to give me 12. So maybe 4 and 3. So I have to plug those in. I check my inside terms and I get 4n. And I check my outside terms and I get 15n. and I need to add these together to get positive 19. I can do that as long as both of these terms are positive. So I found my factors, and they both need to be positive. So my final answer would be 5n plus 4 times n plus 3. Okay, number 5. Again, I'm looking for a GCF. All of these numbers are even, so I'll be able to pull out a 2. And they also all have a v in common. So I'm going to be able to factor out a 2v as my GCF, which is going to leave me with 5v squared plus 11v plus 2. Alright, so I keep that GCF out in front, and now I'll need my 2 parentheses. Whatever I put in the front has to multiply to give me 5v squared, so it must be 5v and v. And then whatever I put in the end of my parentheses has to multiply to give me my product, which is 2. So I'm probably going to use 1 and 2. Now I have to check the inside terms, which give me 1v, and the outside terms, which give me 10v. And I need these to add to give me my sum, which is positive 11. As long as these are both positive, I can get that sum. So I need positive signs in both factors. So I'll have 2v times 5v plus 1 times v plus 2. So sometimes we can try all the wrong numbers like we did on number 4. We had to try it 3 different ways before we found the right terms. And then on number 5, sometimes you guess it right away. So let's do another one together. Here on number 6, first I look for that GCF, and there is none. So I make my 2 sets of parentheses. And I would have to get something that multiplies to give me 2n squared, so it must be 2n and n. And I also need something that's going to multiply to give me 2 for that product. So if it multiplies to give me 2, it's probably 1 and 2, just like we used last time. So I'm going to multiply my inner terms together to check. I get 1n. My outer terms, I get 4n. I need to have that sum of positive 5, which means both of these must be positive. So my factors are 2n plus 1 and n plus 2. Alright, let's do one more together. So, number 7, we've got 28y squared plus 53y plus 7. So there is no GCF here, so I have to go ahead and try and come up with what should go in my parentheses. So I'm thinking whatever I'm putting in the front of my parentheses has to multiply to give me 28y squared. I could use 28y and y, but I can already see that when I multiply to put in my products of 1 and 7, which I'm going to have to put here and here, there's no way multiplying 28 by 7 and adding it to 1 is going to be able to give me that 53 there in the middle. So I'm going to have to pick different factors to go here. So I'm thinking what multiplies to give me 28. So maybe I'll use 4y and 7y. 4y times 7y would give me 28y squared, so we'll start there. Now, to decide what goes in the end of my parentheses, I look at my product, which is 7, and I have to think what multiplies to give me 7. Probably going to use 7 and 1. So, I multiply my inner terms, and I get 49y. I multiply my outer terms, and I get 4y. And I need these to add to give me my sum, which was 53. And as long as these are both positive, that's what I will get. So I end up with 4y plus 7 times 7y plus 1. So, if there are more than one option of what multiplies to give you those first two terms, you may have to try a couple of different things. You might try 1 and 28 first, and then you realize it doesn't work no matter where you put the 1 and 7, and then you would realize that you have to use 4y and 7y. Alright, the rest of the problems are the assignments. You'll just post those in Schoology.